We will examine the real application on the process industry involving analog and digital isolators and how these devices can practically solve situations that are usually handled with more complex and expensive systems.
Okay, Massimo, we can go. It's your turn, please. Okay,
well, Andrea, we can start now. Let me give some information on today's speakers. As already mentioned, I have a pleasure to have with me Andrea Spolaor. Andrea is a global account manager at GMI. He has over 20 years of experience in the machine and process automation market. His main area of activity is in the industrial control process, in hazardous area application involving signal conditioning, remote control, and bus interface. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and market worldwide. Andrea is a functional safety engineer from 2016. And I'm Massimo Pagani, product manager and technical support manager at GM International. I've been employed at GMI for about 11 years, and my main role is to receive and process customer technical requests and assist them in the correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of new devices to be put on the market, and with the sales and marketing offices to promote GMI worldwide. I'm a functional safety engineer from 2020. Well, some words about our company. GM International is an Italian company born from the experience of Elcon Instrument, and for over 25 years has been design, engineering, and manufacturing a complete range of CE-certified intrinsic safety devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in various industrial sectors such as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. All our products are tested one by one and must conform to the strictest worldwide specification. And in addition, all our products are entirely designed and produced in our headquarters in Italy. And last but not least, they are covered by a 5-year warranty. In the next slide, show how GMI is located around the world with over 200 people who make up our staff distributed on all continents. We have products distributed in our main branches in Dubai, Singapore, Houston, and so on. GM International has always been perceptive to market demand. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activity is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their applications and to assist them in the correct use of the product. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in a highly automated process. The goal of our company is to supply and guarantee innovative and high-quality products. All our products are tested one by one and must conform to the strictest worldwide specification. And our products are tested and certified by over 15 independent UV agencies and laboratories. They have certification available for different market applications in Europe, America, Korea, China, India, etc. According to the new ESC 61508, the seal certification of the product is no longer valid if not supported by the systematic capability design certification. For this reason, all our products are designed to adhere to the functional safety management, seal-free systematic capability certification. Additionally, over 10% of GM employees are engaging in research and development of new technologies. Many of our resources are invested in the research and development department. In the next slide, you can see the wide range of products we deal with. Here we can see, yes, barriers, safety relay, isolator, multiplexer, seal-free power supply system, and termination board dedicated to the most popular PLC DCS system, and again are multiplexer and so on. Furthermore, our company promotes advances course of, on functional safety and safety in AX environments conducted by expert training. You can find all the information about it on our website. The last slide lists some of our main collaborators and customers distributed among system vendor, EPC, O&M, and end user. Well, Andrea, it's your turn now to introduce today's topic.
Okay, thank you, Massimo. So today we are talking about Intrinsically Safe Isolators. Is our, as Massimo said, and probably you also know, is our specialties. We are really working on this market from the beginning of the company, and we are on one player that working in the area. And so the presentation starts divided in chapter. First chapter is it's an explanation why Intrinsically Safe is interesting, why is used in the market, what is the concept. It's the first part maybe a little bit boring for you, probably not, but we like to introduce it. But first of all, we have our first poll regarding the EX protection methods. And so we want to ask you what is the basic protection principle for intrinsic safety, if you know, of course, if it is isolation, mitigation, segregation, prevention, or containment. Please answer. It's we take just, of course, 1 minute of your time and our time, and then we go on. Thank you for answering. The information I see there are variable from a lot of different people, and of course there is only one answer which is correct, the other are not correct at all. So let's wait another few seconds and then we will stop this poll. Okay, let's stop it with, of course, I see that there are a lot of strange information not correct, but of course, for intrinsic safety, the methods that we are using, that the system is using the prevention. So there are different protection methods, and we want to, of course, use and explain a little bit the differences. So you may see there are systems for segregation that can be, of course, like EXP, EXO, EXM, EXC. There are different for segregated electronic. And also very used is the containment system, like a flame-proof EXD, that is mainly used in, of course, in mailing from our experience in North American markets. But of course, also it's very important the prevention that is say, located for intrinsic safety and increased safety. And then it's a topic of today. So intrinsic safety is, we can say that it's a very flexible and cost-effective solution, because it's say hardware in the connection are really limited, and it's of course based on an ATEX directive, and the unit that is used for intrinsic safety application is in a barrier, or intrinsically safe barrier. That is the common name that is used for this kind of hardware. But the question is, shall we use or should we use a digital isolated intrinsically safety application? Let's say that the isolator is very important because when you have potential ground differences in the hardware, the isolator is very important for eliminating the fault due to the ground loop. So the current between different level of grounds can be, make not real your measurements, and then maybe you can have some problem in connection and so on. So the isolator is very important. And the isolators, the intrinsically safe isolator, limiting the power for intrinsically safe application. So the power means that the amount of electrical energy in the system is at a level that cannot cause any spark and that cannot cause any explosive situation in the system. But an isolator is not standalone, is an apparatus, but it's not only the component. There was a question from one attendee, we just got it. It's just a component of an IS circuit, and is not, sufficient to keep and to maintain at the safe level an S circuit, because there are other things that must be calculated, and they must be, of course, used in the proper way in order to keep the system in below the minimum explosive level of the area. So there are different isolators. You can use for analog input, analog output, digital input, chip amplifier, different for load cell, vibration. We have a lot of solution we will see later on different slides. Also, temperature is very important in this kind of situation. And but there are, of course, in the isolators, because there are different types. There are isolators, intrinsically safe isolator, and then barriers. So basically, the intrinsically safe isolator give an added value. So you can have a wide range for input outputs. Say source sink for the current, for the PLC and DCS, because not all the PLC and DCS input cards, output cards work in the same way. So those, some are source, some are sink, and of course the apparatus you connect that will be connected with, and the barrier will be connected with the input, must work in the opposite way. So if the PLC is a source, you have to connect the sink current output, and the other way around. You can have, of course, a digital bus communication, for instance, Modbus, burnout, so detection. So if the sensor connected on the input is of course fail, you may have this kind of let's say detection. Isolator have a high accuracy that can have multiple isolation between input, output, and power supply circuit, programmability, configuration, and also installation can be used for DIN rail or customized termination boards. So that was, I would say, the boring part. So now we go through the example of what we have and what the market offers, because not only GMI, of course, but we have a wide range for this application. So let's go for the IS isolator solution application for different signals. So now we have another, of course, another poll. We want to have, of course, your answer and your about what solution do you usually apply if you use intrinsically safe isolators, or if you use Zener barriers. Later we will see the difference between these kind of types. And maybe you also use the PLC DCS system with integrated IS inputs or outputs on, say, connection. Or maybe use other type like EXD, EXP protection systems. If you just answer to this question, then we go on again. Okay, no more answer from you. Okay. Okay, we're gonna stop it. Thank you. And then we wanna share with you the result. So we see that most of you use intrinsically safe isolators, some of you Zener berries, some of you, of course, PLC/DCS with the system integrated with the inputs already dedicated. Okay, thank you. And we go again. So now we see the analog input. So we have solutions and the market offer. Let's talk about in general, but of course we have example what GEMI is offering. So solutions you see for IS with the module with the blue label you see on the on the bottom part, or with a gray label that are for non-AS applications. But more or less the technology is the same. So a unit for 4 to 20 milliampere current repeaters with passive and active transmitters connection, so you can have 2, 3, or 4 wire inputs depending on the sensor. Functionality like signal duplication, like source and sink output, or voltage output. All of them are, of course, hard compatible, and they have certification SAIL 2 or SAIL 3 that is often required nowadays on all isolators. We see the solution for the dual channel here, and then here the solution that can be used for duplication. So you want to connect mostly for redundant, say, applications, you want to connect the input to 2 different cards on your systems. So the connection is here for 2 wire or for 3 or 4 wire sensors. We have also solution with multiple channel with 4 channels, completely independent, and possibility of having some so matrix configuration, or there is a small PLC can be used with a 4 dependent channel, or say a sort of calculation, addition, subtraction, whatever you like, is free configurable by software. And this solution is also with the Modbus, say, interface. We have a solution also with for trip alarm. So with the 4 to 20 milliampere signal input and output that is 4 to 20, just the transmission. And there are also 2 relay output for alarm if you want to set some threshold on the values you are reading on your sensor input. Massimo, I leave you this part regarding the line monitoring.
Yes, well, let's see how analog input devices can manage a line fault. A 420 milliamp current signal allows us to standardize the measurement, and using the Namur standard, we know that in the range between 3.6 milliamp and 21 milliamp, the measurement is valid and correct. The analog barriers allow us to read and mirror a signal that goes from 0 to a maximum of 26, 30 milliamps towards the PLC/DCS system. In fact, the barrier has the main purpose of limiting the current in the loop to a non-dangerous level, which allows us not to generate a danger of explosion. This precise standard allows us to program our PLC to provide us with a line fault when the set thresholds are exceeded, or in case of using devices with the programmable alarm threshold on boards, to provide a single fault counter or cumulative fault to a DCS system. Let's now analyze how to obtain a core system redundancy through trip amplifier devices. One of the typical applications which uses a redundant system with several devices, analog in this case, is what we can see in the following slide, where 2 out of 3 redundant system of trip amplifier is used to activate our final element. This system and its redundant logic allow us to replace more complex system composed of safety PLC, for example, allowing us to save more engineering cost. But let's see specifically the 3 trip amplifier devices each have 2 Allen relay outputs with the individually programmable threshold, and each of them is SIL2. By programming all the Allen threshold of the trip amplifier in the same way and connected in the way we see in the slide, the relay outputs in such a way as to compose a matrix of contacts, which allow us to obtain a SIL3 level from a component SIL2. This is to activate the final element at least 2 of the 3 loops sensor plus trip amplifier must perform the same variable measurement in the field and correctly process the data. In fact, when at least 2 out of 3 sensors detect the same variable in the field, the related trip amplifier will activate their contacts and consequently the final element is activated. If one of the elements in the field fails, or if one of the trip amplifier fails, the 2 out of 3 redundancy allow to maintain our safety function and process availability at night level. I repeat, this type of logic would be possible in another way only by using a PLC system with the redundant cards, having a considerably higher cost. This system allows us to achieve a high SIL3 safety standard with high process availability. Well, Andrea, it's your turn for analog output device.
Okay, thank you, Massimo. So for analog output, we have solutions for single dual channel with that can support the hard signal, of course, in a transparent way. That can be used for signal duplication, so in this case for redundant applications, and also in this case offering the loop monitoring open short, and Massimo will explain on the next slides.
Okay, also in this case also in case of analog outputs, let's see how a line or load fault is managed. In this case, it's the barrier itself, in addition to limiting the current and voltage towards the fields to non-dangerous levels, that carry out a real diagnosis of the loop towards the hazardous area. In fact, the internal circuit of the barrier is designed to provide us with a real fault signal when very precise thresholds are exceeded. In case of the GMI device in the slide, it's able to detect a short circuit fault when the impedance of the load and the line falls below 50 ohm or 100 ohm. This threshold can be set via the internal dip switch. However, as for the open circuit, it's signaled when the threshold given by the formula 21 divide loop current minus 300 ohm is exceeded. This threshold, as you can understand from the formula, is strongly dependent on the current that the PLC supplies to the loop. But how is this fault reported to the system? There are 2 ways. The first involves the use of a fault contact which is opened when the fault is detected and sent to a digital input card of a dedicated DCS system. In addition, a LED on the barrier red typically is turned on. The second method is the mirroring of the fault directed to the analog output card of the PLC. If the PLC is compatible with this system and the supervised analog output card is able to detect a change in impedance at its input, this system allows not to use a dedicated DCS and to save costs related to it. In fact, when a fault is detected, the various input circuit goes into an high impedance condition, typically higher than 5 kiloohms, causing a maximum current lower than 2 milliamps to circulate in the input loop. In this way, the PLC analog output card, if supervised and able to receive this impedance variation, will understand that a fault has occurred in the field and will signal a fault. This system guarantees considerable saving in terms of cost, as it supervises the loop without the need to add a dedicated DCS system for this purpose. Now, let's see how
Massimo, I think it's important for our attendees, this kind of monitoring, say, of course, the values that is reflected to the PLC DCS is, of course, depends, of course, because there are PLC and DCS that can acquire and can detect it and other not. But I think we test a lot of this kind of situation with different PLC, and we can also, if the attendees need to have this report or maybe have say, recommendation for using different cards. We have a lot of experience of also test report in our database that for their own use.
Yes, correct.
Okay, good.
Okay.
Again to you, yeah.
Yeah, let's see how it's possible to manage a redundancy system for analog output type application. In this specific application, the management of 2 for 20 milliamp signal towards the dangerous area is not a simple solution, as the two signals should be mixed or added in some way. GMI has developed a redundancy system through a special termination board, which takes two signals coming from two different analog output cards of two different PLC systems and mixes them through its own process logic. In fact, when we will have a main command signal called master and support of it a command called slave. The two signals arrive at the terminals of the termination board and at the input of an electronic switch placed on board it. If both signals are regular, the master commands the loop and drives our load in the field. When this master signal fails due to a line fault or because the relative analog output card fails, the current signal relative to it goes to 0, and the electronic switch placed on the termination board switches to the slave signal, making ensure that the output load continues to be correctly powered. When the master signal is restored, the electronic switch on the termination board switches back to the master signal. In addition, we can say that the switching speed between master and slave will be less than 1 millisecond. Through this switching logic, it's possible to carry out redundancy also for analog output circuit. There are two ways to different concepts for the use of redundancy. The one that looks at the safety of the process and the one that looks at the availability of the process. The two philosophies of redundancy are in contrast with each other, and the end user must choose which way to go. GMI's analog output redundancy satisfies the concept of process availability, allowing our plant to continue its work even if one of the components in the field fails. GM solution tries to simplify the redundancy logic to try to obtain the best possible result. Well, Andrea, we can skip to the digital input device.
Okay. So digital input, we have a solution also in this case for single dual channel, for IS or non-IS. Connection is for proximity sensor or switches. You see this, the connection proximity, and also for the contacts. There is a small drawing. Let me highlight this part because maybe it's also important for you. So you can see here the part for voltage view where there are two resistors for having the line monitoring functionalities. And we have the possibility to use some modules like also duplicator. So the same contact is sent to two different cards. It can be used as a duplicator. So the second output is for duplication or for alarm. We have solution for the proximity repeater for the cards that allow this kind of inputs for IS and non-IS applications. And also there are solution for with 8 contacts, 8 proximity or 8 contacts in the same modules. Also in this case, like for the analog, there is a possibility for configuring the input for having, say, such combination on the output, sort of logic. Everything is really user configurable via our software, free software. And of course, there is loop monitoring functionality. Yeah, Massimo, maybe you can explain better this part.
Yes, we focus on 2 particular digital input models that GMI has developed, models that are C2 and C3, able of transparently transferring the status of an Amour sensor or contact in the field to a supervised digital input card of a PLC. This allows our safety system to know exactly the state of the loop in the field. Furthermore, this transparency makes it possible not to use a dedicated DCS system for detecting a fault, as in case of using a normal digital barrier, which needs to interpret 2 contacts to understand the state of the input loop. But how does this transparency work? Well, through a network of resistors connected to transistors, the barrier output is able to provide the exact state of our input. In fact, when the contact in the field is in open condition, we will have the transistor in series with the output loop active and with its contact closed, while the transistor in parallel to the RH minus RL resistance open. In this way, an impedance value equal RH will be seen by the PLC. The PLC digital input card, which applies a voltage typically of 24 volt DC to this impedance, will read a return current value corresponding to the 0 state of the contact. On the other hand, when the contact in the field is in the closed condition, RH minus RL is short-circuited by the transistor in parallel with it, and the PLC will see an impedance of the value of RL. In the same way as before, the digital input card that applies a voltage to the loop will read a return current value equal to the closed state of the contact in the field. But what happens in the event of a fault detected in the field? In the event of a fault in the field, whether it's a short circuit or an open circuit, the transistor in series with the output loop opens, and an impedance is shown towards the PLC digital input card, which is read by the PLC as a bad signal or fault. This network of resistor at the barrier output allow us to obtain a mirroring system of the fault towards the PLC. Let's see now some particular
just a few words, Massimo, for this type of modules.
Yes, please.
Develop a special version dedicated for different PLCs, because we have seen that not all RH and LA resistance are, let's say, are suitable values to be read as fault, as a good condition for the PLC. So we have dedicated modules, for instance, for Honeywell, for Schneider Electric, but not all type. Tricon is one thing, so, Modicon, M5 and 8 is different. So let's say have a look. If you have any special application, we can suggest the right one, and maybe also develop a new one for new PLCs if you're using special. Okay, so let's go further. Massimo?
Yes, let's see now some particular application that involve in digital input isolator. The typical application is where we have to isolate a voltage-free contact or an Amour sensor in the field. And in this case, we use the classic digital input barrier or an isolator. But what happens if in the field we have a voltage, 24 volt, 48 volts, 110 volt DC, and we have to signal to our system the presence or absence of this voltage. In this case, a digital input device cannot be used because its input front end and its input front end is not available to accept external voltages from the field. In this case, we should use a digital output relay that is a device that, depending on the voltage that arrives at its command, activate or deactivate an output contact and communicates to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate to PLC DCS system placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while a digital input card receives the contact status of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? Well, first of all, we have to keep in mind that usually a relay is designed to switch important value of current, while usually towards a digital input system, the currents in play are very low, typically less than 100 milliamp. In this situation, we can face problems of oxidation of the relay contacts. Therefore, it's essential to choose a safety relay with golden plate contacts, which consent switching thanks to its high conductive performances, even current lower than 10 milliamps. To deal with this problem, GMI has equipped most of the relay of the new D5000 series with golden plate contacts to make them available to this particular application. In addition, GMI has developed an universal device able to receive at its input different voltage level, 24 volt DC, 48 volt DC, to 230 volt AC, and so on, selectable via this switch. While the output provides a free contact voltage, optocoupled type, compatible with all PLC DCS systems, which ensure maximum conductivity even at lower currents. This device is specifically designed to work in this kind of application, where we have to communicate between two systems distant from each other, or where we have to signal to a system presence or absence of voltage. Of course, diagnosing a wet contact in the field is difficult, but how it's possible to understand and differentiate the closed state of a contact from a short circuit? And again, how can we distinguish between the open state of a contact and an open circuit fault? This condition make us think that diagnosing wet contact from voltage in the field is impossible, but GMIS, through one of its analog devices, has studied a possible solution to overcome this problem and be able to provide diagnostic of a wet contact in the field. In fact, using a trip amplifier and connecting it with a network of resistors to the contact in the field, we can obtain voltage level at the input of the device that allow us to discriminate one state from another. Furthermore, by programming our trip amplifier with interpretation threshold, we can provide the PLC with a different state of for each condition of the input contacts, being able to diagnose the normal operating state of the contact from a fault state. Let's see, for example, a wet field contact from 125 volt DC. The diagnosis of a voltage is made possible through the use of a specially programmed D6254S, and with the insertion of some partition resistance to make the 125 volt DC compatible with the voltage input of the D6254S module. In the slide, we can see the diagram and the configuration of the isolator used for the application. So we will have that with S1 contact open, at the output of the module, a resistance level will be presented, which will be read by the PLC as an off state. Contact S1 closed, it will give us a resistance level that the PLC will interpret as a on state. First state, fault in the field, cable break, as example, at the input. We will have a fault at the output with the opening of the relay commanded by alarm 2. In this case, the PLC will see a fault status. Of course, the PLC card must be of the supervised type. Well, Andrea, I think we can jump to the digital output device.
Also, in this case, digital output, we have a solution, different types, single dual channel with different, you see, selectable outputs for different, if you have a sensor require different or more output, that can be used, of course, in compliance with the area where the sensor is located or the load. We have also solution in this case with line monitoring for open and short. That will be also the discussion for one of the next slides. And so in this case, there are also 3 different selectable outputs for different loads. We have a solution with the multiple channel with the 3 outputs also, and that can save, of course, the solution with the 3 output can save in terms of overall cost, because instead of your 3 modules, you can use just 1 module. Massimo, this is the slide regarding the line monitoring for digital outputs.
Yes, Andrea, also for digital output modules, GMI offer model with onboard line and load diagnostic to monitor loop in hazardous area. The model D5048S loop power and D5049S bus power, based on the impedance of the load in the field, are able to check the health of the loop and in the event of a fault, generate a signal to the PLC directly to the digital output card, or through the classic voltage-free contact to a dedicated DCS digital input card. The D5048S, being a loop power buyer for normally energized load, is able of monitoring the impedance of the input loop when the load is on. If it sees an impedance below 50 ohms, it detects a short circuit fault, and on the PLC side, it transfers the information directly to the digital output card, showing an high impedance which translates into a loop current of less than 2 milliamps. When instead the impedance of the load, on the other hand, exceeds 10 kilo ohm, the barrier sees an open circuit fault, and in the same way as before, show an high impedance to the digital output card of the PLC. The signaling of a fault can also occur through a voltage-free contact to be acquired through a dedicated DCS system, or through a full LED placed on the front of the barrier. The D5049S, on the other hand, being bus-powered, provides a complete diagnostic towards the field, both in both conditions of load, on and off. Like the D5048S, it can transfer the fault information directly to the digital output card of the PLC with an high impedance variation, or through a voltage-free contact to be acquired with the digital input card of a DCS dedicated to this purpose. Let's now take a look at the redundancy problem also for intrinsically safe digital output application. Basically, there are 3 ways to obtain the redundancy of the system with 3 different levels of redundancy. The first redundancy system involves all the elements that make up the loop, from the valve in the field to the intrinsically safe barrier to the PLC card that controls the loop. This is certainly the most effective and safest redundancy system, but also the most expensive, as to create the redundancy of all elements of the loop as considerable cost. The intermediate way would be to redundant all the device except the final element, that is the valve. This means having 2 barriers and 2 cards controlling the loop. The main problem that arises in this case is that the redundancy up to the barriers forces us to mix the output signal to the barriers. This is feasible, but this is feasible from the theoretical point of view, but first of all, it involves the rating of the intrinsically safe loop from EA to EB, which means that the final element cannot be installed in zone 0, but only in zone 1, and also involve the difficulty to find a final element compatible with the safety parameters that are adapted, having to put the outputs of the true intrinsically safe barrier in parallel. This is certainly the most complex method to implement. But let's see which is the cost-effective and simplest way to redundant this digital output device, where redundancy is obtained up to the digital output card of the PLC. After that, through 2 diodes, we mix the common signal coming from the 2 digital out at the input of a single barrier that guides our final element. This is the simplest system, as by not performing operation that add currents in the hazardous area, there are no problem in terms of compatibility with the final elements. And moreover, it's certainly the cost-effective solution, as the redundancy of the device reaches the PLC only. In the next slide, we encountered a digital out application where we were asked to be able to control a final element, typically a valve, by controlling it with 2 digital output cards. The final element, normally energized, must be de-energized only if both digital output cards give the signal switch off command. The solution studied to obtain a high availability to the process and to keep the plant always active in order not to have losses in terms of production cost, can be obtained through a double channel slip-free relay with the output constants placed in parallel. In fact, in this way, the load will be energized only if both digital output give the shutdown command. Of course, this solution is to the disadvantages of safety, as putting the output contacts of a slip-free relay in parallel leads to an increase in possible dangerous failures. But thanks to the GMI relay, we are still able to maintain a SIL2 level of application and obtain a high process availability. A different application where we were asked to create a nice security loop where the final element was de-energized when only one of the two DO send the shutdown command. In this case, always using the same double channel slip-free relay, the desired safety function can be obtained by placing the relay output contact in series. In this way, the slip-free level of the loop is increased to obtain the required function. This application makes us understand that sometimes it's possible to increase the safety or the availability to the process by combining low-cost but very smart solutions, such as tools proposed by GMI. Well, Andrea, it's your turn.
Yes, okay, Massimo, thank you. And we have a solution for temperature also, as isolators and converters. Probably you can see that we have a solution for thermocouples and RTDs, different connection, 2, 3, and 4 wires. Output also in this case is can be source or sink to be adapted to different PLC cards and modulars. And with also very important full wire monitoring like burnout and other, let's say, alarm compatibility. We have also solution like a simple isolator. So if your cards is already able to accept TC or thermocouples or RTDs directly, you can use this isolator. This is interesting because it's a applications when you have an IS, you have an intrinsic in a hazardous area, you have a sensor and you want to acquire through your PLC card. So you need this kind of IS interface. And we do have also solution with converters with alarms solution. So beside the 4020 milliamps, you have the 2 alarms for monitoring temperature. It can be high alarm, low alarm, mid alarm, whatever you like. It's very completely configurable through software. And that's why Massimo explained a little bit about the software here. So some details, not too much, but in order to give you an idea.
Yes, Andrea, a few words about the configuration software of the GM D5000 series barrier or device. Through this software, it's possible to configure and read all the parameters related to our devices and variables in the field, save and reload data and configuration in a local hard drive, monitor the variables in the field in real time to verify the correct functioning of the loop, and finally record monitoring session and save them in a file. In the slide, we see the configuration windows of our D5072S temperature converter, where it's possible to configure the type of input sensor, including thermocouples, RTD potentiometer, or signal in millivolts. The output parameters are fully user configurable. The possibility of creating a custom table is also available, where for specific application, the customer can create a table of input value for particular sensors, such as PTC, for example. And again, the monitoring session, where it's possible to check the parameters of the input variable and the health of the loop in real time. We can say that all our D5000 series devices can be configured with this software to perform their main functions or to obtain special function. Well,
okay, Massimo, we have solutions for weighing application, for load cell, for strain gauge, as you call it, and so for basically for tank monitoring application, where you have load cell maybe connected to the different parts of the tank you want to acquire through your 420 milliamps. Let's call this more amplifier in case of load cell 2 milliamp. So we have also load cell repeater if your system will acquire directly load cell signals. And we have also for solution for vibration monitoring for turbines, application for compressors, where you have vibration sensors. And this is in this case also an amplifier for this kind of solution. Yeah, we have an application, Massimo, for accelerometer.
Yes, particular applications are using both devices such as accelerometers or vibration sensor. Accelerometers are devices that measure the vibration or acceleration of the movement of a structure. The force generated by vibration or a variation in a movement causes the mass to compress the piezoelectric material, which generates an electrical charge proportional to the force exerted on it. Transducers for measuring acceleration and vibration are increasingly used in the mechanical and structural field, vehicle testing, industrial monitoring, predictive maintenance, bench and room test, or, for example, aerospace experimentation. When these accelerometers operate in a classified area, they must be isolated through an intrinsically safe barrier. As in the slide, the D5062S isolates this particular type of sensor transparently, providing a reading system placed in the safe area with a waveform of the same level and frequencies as that generated by the sensor, so that the system can read the signal correctly. It provides a fully floating DC supply for energized vibration transducer accelerometers or two free wire sensors located in a hazardous area, and repeat the sensor input voltage in a totally isolated circuit located in safe area to drive vibration monitors or analyze for rotating machinery control and supervise purpose.
Okay, Massimo. So, well, we finished a little bit about this part, and now we come to the end of this presentation. So we want to ask you what kind of feature you consider important for IS interfaces based on what we showed today and what is your experience in the application. So if it's important, the single channel, the multiple channel, the line monitor, where we have of course spent a lot of time today, the configuration software, the seal certified modules also, if it's important seal certification, or probably the math functionalities. Thank you for answering. That is very important for us also for, let's say, future development, because our company is always engaged in new products, new solutions, because we listen to our customers and our people, because what is the perception of the company maybe is different from the field application, from what the customer is looking for, what is the troubles in the field, what is would be the really functionality that would be, say, added to the existing modules or new modules. Okay, thank you. You are answering. Thank you very much. Gonna stop it. You can, it's a multiple choice, so you can, of course, select more answer. Okay, thank you. And okay, I see that people are still answering. We want to stop it because we are out of the time as usual. But I think it's also interesting for you. So we see that multiple channel line monitoring are the most important features. Thank you. So now we have the Modbus interface, and then we go to the conclusion. So Massimo, we can go quickly through the Modbus solution. What is important for Modbus?
Yes, Modbus. Many of our devices use Modbus to communicate, but what is Modbus? Modbus is a serial communication protocol that connects programmable logic controls. It has become a standard in industrial communication and is currently one of the most popular connection protocols in the world among industrial electronic devices. But the main reason for such as an high use of Modbus compared to the other communication protocols are designed with industrial uses in mind. It's an openly published and royalty-free protocol, easy of installation and maintenance, and it moves raw bit and works without placing many restrictions on producer. Well, in the next slide, Modbus, we see how Modbus works. Modbus RTU is an open serial protocol, widely accepted due to its ease of use and reliability. Up to 127 modules can be arranged in a multi-drop network, and the monitor configured by a single master unit, as shown in the following picture. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and where request makes available its value for reading and writing. And again, complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a master Modbus master is available on the system side. Well, what are the advantages of using Modbus communication? With a single Modbus RS485 interface possible to connect and communicate with all the devices present on the same bus. Multi-drop connection is possible and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input card system to monitor alarms. This allows us to have significant saving in terms of cost. And again, with models, we have real-time information on the type of alarm and on the health of the load and line connected to our device. And via Modbus, it's also possible a complete remote programming of the device. Well, Andrea, we can go for the conclusion of our...
some information about device supporting Modbus. So you still have this part. So some modules, we have a solution for analog input, digital output, others, and temperature. But all of them offer the Modbus capability. Massimo, you want to have...
we have another application that we can show. In the next slide, we examine an application where a sensor installed in a hazardous area must communicate via RS485 with the control unit located in a safe area. This sensor located in a hazardous area must be isolated and powered through two barriers. One barrier will supply power to the classified area so that the sensor is protected and cannot generate spark that can cause an explosion. The other barrier will have to provide isolation of the RS485 bus line so that it cannot connect with the unit control. The advantage of using this specific connection is the possibility of connecting up to 32 devices in multi-drop mode on a single bus, which allow us to form an integrated network of devices with considerable saving on installation cost. When installing a device with bus interface in an hazardous area, there are two ES barriers that need to be installed, a power barrier and signal barrier. The signal and the power are two separate ES circuits, so they must comply with the proper ES segregation distance. Well, Andrea.
Okay, now we have the conclusions, and so we want to give you details, looking at a different solution as for purging pressurization, explosion proof of safety, or intrinsic safety. Look at the explosion proof, and we see that intrinsic safety is more safe because with limited power energy, as you understand, is more flexible because of course there are questions on the wire and the situation, maybe modules can be changed. So it's not, we are not, it's not requiring a dedicated, let's say, housing, the cabinet and so on. Also, installation costs are lower and maintenance cost is definitely lower because it is a solution that also is the only one that allow live maintenance of the system. Of course, cannot be used everywhere because intrinsic safety is only when there is a limited power. It cannot say power or control a motor and everything that we like. No, it's only limited to certain applications. But when it's possible, it's definitely the most interesting solution. But we want to also give you other details because there was a question from one attendee in the beginning of this presentation. So the only use of an isolator or barriers is not a sufficient condition for achieving safety as a location. So, so the isolator barriers, of course, certification must be in compliance with the area classification. That is very important. Also, the field device that must be complete with the area classification. You cannot use a field device for zone 0 if it's not certified for zone 0. The safety parameters of the field device and the associated apparatus like an isolator must match. We see later. Also, the cable parameters must match. That is very important. And max temperature in compliance with the area classification is very, very important. So here an example. You have a temperature transmitter, you have the barriers, the isolators. There are few parameters like for the transmitters, like UI, in this case 30 volt, II, 130 milliamps, PI, 800 milliwatt, CI, and plus CC. So CI is for the transmitter, CC is for the cable, LI is for the transmitter, and LC is the cable. So you see here that the parameters for the cables are entering to the calculation. So, and these parameters, of course, must match with the isolators we are using in the application. So, in this case, our UO must be lower than UI, IO must be lower than II, PO must be lower than PI. The other way around, CO must be higher and LO must be higher than the other, so the association transmitters plus cable. So also the length of cable is very important because, of course, the more length, more long is the cable, more, let's say, effect has on the calculation. In our website, there is a tool, loop verificator, where you can calculate it easily. You just enter the parameter of the transmitter you have and the cable you have, and you associate the module we have, you want to use it, and you can at the end with the calculation. And if the loop is verified, you get all green values. Another details is about Zener barriers and isolated barriers. So we see that people are using Zener barriers. Of course, there is a limited mark, but still used. We can say that is, in terms of cost, is definitely lower. But of course, now technology is going ahead, and also the cost for an isolator is lower than in the past. It's a very simple design. It's completely loop powered. There are some voltage drop issues. But the most important things that require dedicated hard connection. So any application that is applying Zener barriers require hard connections dedicated, and it must be verified regularly. While an isolated barrier is a little bit more expensive, it's bigger, it's of course not small, not a simple design like for the Ziners, and but it can be used with any sensors. With a grounded sensor, there is no problem in application, and don't require any Earth connection. So that is the most important thing. So if we look at the term of cost, Zener barriers is definitely important, is more interesting. But looking at the application, well, the installation, the calculation, the whatever is probably the isolated barrier is more convenient. So, question answer. If you have any question, probably you should have already written the box, but I didn't see anything. But anyhow, we are here. You can look at our website where there are all documentation, the priority certification, and so on. And our worldwide contact, we have a complete network all over the world that can support you. We remind you our live webinar schedule on our website. You can see next webinars that will be displayed and promoted over LinkedIn, of course. You can also look at this registration because this has been recorded in our YouTube channel. You may see also the other webinars that we did for different topics like functional safety, EX, and other cybersecurity also. So there are a lot of different webinars recorded. You can look and share with your colleagues. But last poll, and then we finish. We ask you how we did it, if it was good for you or not. We, of course, your comments are very important because that's important for us for improving our, say, communication. And of course, we try to be excellent, we try to be positive, but also we can write poor and not what expected, because sometimes the customer is expecting different things from what is receiving. But this is anonymous, so you can, of course, don't worry what you answer. Okay, thank you very much. Thank you very much again. I'm gonna stop it. Okay, this, and we want to also remind you our name, our email address, you can write it, and our faces. We are on LinkedIn, so if you want to get in touch with us, just ask for the connection with it, of course. And thank you, Massimo.
Thank you, Andrea, and thank you to all our attendees. See you in the next webinar.
Sure. Thank you. Bye-bye.